Yeah, okay, cool. Yeah, I mean, she's rounding right here. She's saying, it's about 11. That's pretty good because that's all we need it for. Like, we don't need it to round it to the nearest tenth or anything like that, because if it's about 11, just go underneath 23 over half, 23 half over 2 over there, and write 11. So now we have those numbers. How would we range those from greatest to least, honey? Which one is the biggest? Okay, sorry about that. Let's answer these. All right. 88.7192. This is going to be a rational number because it stops right there with a 2. That is a terminating decimal. That would be completely different question if you had the little dot, dot, dot right there. So if it does not have those dot, dot, dots and it's a decimal, it is a rational number every single time. Now, not every single number has little dot, dot, dots is an irrational number, but if it is irrational, it's going to have those little dots. That is a rational number because it's a terminating decimal. I'm just going to put term des. Negative 17 divided by 3. That is also a rational number. Negatives have nothing to do with whether it's rational or irrational or not. 17 over 3 is a fraction. Negative 17 over 3, that is going to be a rational number. Now, this next one, I'm going to put, meh. There's not really enough information. You know what I mean? Like 1.131413. I could make the argument that the next number would be a 1, and it's a repeating decimal. 131413141314. You could also make the argument like there's not really enough information. I'm not going to give you anything like that, but if I was just going to answer that one, I'd say it's rational because it's a repeating decimal. 131413. I'd say the next number would be a 1. But I'm not going to give you anything like that. It's either going to be, there's not going to be any gray area whether it could or could not be. If you get it wrong, it's because when I show you the right answer, when I show you why it's wrong, you're going to be like, oh yeah. It's not going to be like, well, no, I think the next number is going to be, it's not going to be like that, right? 3 times the square root of 2, this is an irrational number because the square root of 2 is a non-perfect square, and you multiply 3 by a non-perfect square, like 1.14136. When you multiply that by 3, you're going to get something like, I don't know, 4.19632142, dot, 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 dot. All right? 15 is a rational number. That does not say the square root of 15. That says 15. 15 is a rational number. It's an integer. 201.719246. This is an irrational number. That is a decimal that goes on and on and on forever. It's not repeating in any way, so that's going to be an irrational number. The next one, you're going to see this in trigonometry a lot. 2 pi over 3. Yes, it is a fraction, and fractions are going to be rational. However, you have an irrational number in the numerator. 2 times pi is something like 6.314269 dot 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 dot, and when you divide that by 3, you're going to get something else like 2.163412. If it has a irrational number in it, it's going to be irrational, okay, whether it's a fraction or not. So that's irrational as well because it has pi. Square root of 200, this is a non-perfect square. This is also going to be irrational. Square root of 200 is an irrational number. That's the whole reason why we're talking about this. It's because it's the square root of a non-perfect square. Negative 5 7/9. Just because it is a crazy fraction, just because it is a mixed number, just because it's negative, doesn't have anything to do with whether or not it's rational. Or it doesn't have anything to do with it being an irrational number. That's just there for the kids that are not paying attention. Negative square root of 289. If you don't know your perfect squares off the top of your head, you're going to think this is an irrational number, but this is really a rational number because it's another way of writing negative 17. Square root of 289 is 17. The negative sign in front means the whole thing's going to be negative. So it's negative 17. 0.000918. It's a terminating decimal. It's rational. If little dots, dots are behind it, that's a different question. This is a repeating decimal. I know what the next number would be. It'd be 3. Negative 8.398398,398, dot, 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 dot. The next number would be 3. 0. Rational number. Square root of 2. Irrational. Not a perfect square. Square root of 2 is not a perfect square, or 2 is not a perfect square, so the square root of 2 is irrational. 5.61890,618. Again, I'm going to say that this is rational because I think the next number would be a 9, and then after that would be a 0, and then after that would be a 6. I'm not going to really try to trick you like that, but there are going to be questions like that that are designed to see if you know what you're doing here. Like, just, and I'll show you what I'm talking about here in the next section. I'll explain that a little bit more. Okay, square root of 200. This is going to be an irrational number. 200 is not a perfect square. Oh, it's just like that one up there. So these are both irrational. Good thing I got the same answer. 6 times pi. This is going to be an irrational number. It has pi in it. Square root of 2 over 3. Irrational. We already said the square root of 2 is irrational. So the square root of 2 divided by 3 is going to be irrational. Pi divided by pi. Oh my goodness. I see pi. It's got to be irrational. Anything divided by itself. And I mean, this is one of those trickier type questions. Anything divided by itself is 1. Pi divided by pi is another way of writing 1. 1 is an integer. 24.910798. Or 9107898. This is an irrational number. Keeps going on and on and on forever. Okay, so the questions that you are going to see more often than not on your test, on your midterm, on your final, on your milestone, on whatever, your quiz, it's going to say, which of the following is irrational? And it'll say like A is 15, B is negative 3.51792, C is going to be the square root of 18, and D is going to be 5.1. Sorry, 5.1. Which of those is irrational? You know, I can see where kids would think, okay, well, 15 is not a perfect square, and then negative 3.500, it's going to be B, or this one right here, negative 3.51792. If you see the square root of a non-perfect square, your answer is that every time. Those other questions are up there to throw you off. The square root of 18 is the whole reason why we're talking about this right now. All right. The other way, I mean, that could be written is the square root of 16, the square root of 17, the square root of 18, the square root of 19. Which of those is a rational number? You got to know that the square root of 16 is another way of writing 4. All the other ones are non-perfect squares. When you take the square root of non-perfect squares, it's going to be irrational. You know, which of the following is rational? You know, pi over 2. Square roots of 324, square root of 500, and then negative 4.19 or 4.91725 ... That's a 4. Well, even if it was a 9, it doesn't really make a difference. Which one of those numbers is rational? You got to recognize that the square root of non-perfect squares is going to be irrational, but the square root of perfect squares is going to be rational. Your answer would be the square root of 324. Another way of writing 18. All right. Good job, little children.